Hello students, I'll wait to join each and everyone. After that, I'll start your class. So today, first I'll discuss the points related to JMN 2026. Wait for some time. I'll start class. Hello, hello student. Wait for remaining students. I'll start after 5 to 10 minutes. They can share link with your family and friends so that maximum person get benefit. Okay. Students, audio, video, visual view, say hi. Just make your attendance. As your attendance, you can mark hi. If audio, video, visual for you, is there any students? Is there any problem in audio, video? So you can write in comment box. Uh, Wait till 7:50. Student, stay in the meeting, stay in the live session. I'll start class as usual 7:50. Student confirm me. Student confirm me. Is there any issue in audio, video? Is there any issue in audio, video? Say yes or no, right in comment box so that I can start your class. Time already gone, 10 minutes. Till now, I'm not getting any confirmation from your side. Students, can you confirm me? Audio, video clear for you? Uh, Very good evening, student. Okay. So now, students, initially, first I'll discuss few points. Uh, J May 2026. This is a point related to those candidates who will go to write J 2026 paper. So, student, these are the points to avoid. These are the points to avoid in 2026 J mains examination, right? So what is the point which you have to avoid, student? This is first one. This is the first one. This is the first one. Students, maintain maintain your calculation potential. Make sure which you are calculating. Each and everything must should be, students, crystal clear, and try to avoid any calculation error. That is the first point. Second point, students, I can say, what's the point number two? Students, keep keep yourself calm. This is a very, students, it's a very mystery point. Without mentioning calm of your body, of your soul, you can't calculate, you can't get correct answer and correct options of any questions. So keep in your mind, stay happy, keep with you 1 liter, around 500 milliliter, like bottle, high water with you, so that time to time you can drink the water, and just maintain. These are the primary things. Maintain against your calculation potential. Keep your self calm. Point number third, students, what I can say, just uh, recalculate or recheck. Student, recheck is extremely important. Recheck is what extremely important. Recheck your answer, just go through what you already calculated, which you marked. Because students, after the examination hall, many students shared with me, sir, actually I calculated everything is fine, all things are correct, but during marking, I bubbled options B instead of options A. So avoid this kind of error. So students, I can say, avoid avoid error during marking the bubble. So these are the, I can say, fair point which students you can keep in your mind during the paper. So now, students, I call you everyone for the class as well. So now, already time going, already gone, 7:15. So, 14, I'm going to start your class as usual. So, what is the topic of today class, right, students? So, today class, I'll discuss, that is, students, it's a literally very core and vital topic for mechanics, or I can say 11th class. Major questions you will get fluid, literally, and it's a highly important to students. So, first, I can say this is lecture one. Student, this is the lecture one, for I can say this is fluid mechanics. Students, this is lecture one for fluid mechanics, right? So you can ask, sir, what is the fluid mechanics? Before going to start the topics, literally, students, we have to understand what is the fluid mechanics. So, fluid mechanics deals with the behavior of fluids at rest in motion. What is fluid? Again, I'll repeat, or I'm writing fluid, student, fluid mechanics, students, fluid mechanics deals, fluid mechanics deals with the behavior of fluids at rest and in motion. Yes, a student. Basically, in this chapter, I'll discuss I'll discuss the students fluid in two things, right? So this is what you can see: fluid statics and fluid dynamics, right, students? So now I'm going to categorize. Now, students, I'm going to categorize. This is fluid mechanics. Students, this is fluid mechanics, right? Students, in this chapter, we shall study of fluid statics and fluid dynamics. What is student? In this chapter, we shall study fluid static and fluid dynamic. So now, students, I can say there are two categories in this chapter. I'll discuss these two topics individually. So now, students, in this chapter, we shall study this is fluid statics. What is student? Fluid statics. And what is the next one? This is fluid dynamics. What beta Z? This is what you can say fluid dynamics, right? So now I'll discuss, I can say individually, but little point I wanted to connect here, little only. So what is the fluid statics, right? So students in fluid static student, fluid statics is the study of behavior of student fluid at rest. It's a student's chapter for 11th class and it's literally highly important. What's the fluid static? Fluid static is the study of behavior of fluid at rest. That's all. Now, students, what is the things which I'll discuss under fluid statics? What is the point which I'll discuss under fluid statics? Students, for fluid statics, what is the major point, student? I can see for statics, it includes students, it includes fluid pressure, fluid pressure, Pascal's law, students, Pascal's law, and Archimedes, Archimedes principle. This is what Vitaji will discuss. This is the major point for fluid statics. What's the major point which I'll discuss one by one? That is the fluid pressure student. Next, Pascal's law. And third is what you can see Archimedes principle. Right? Okay, students. Okay. I'll repeat, students. So now, what is the fluid mechanics? Fluid mechanics deals with the behavior of fluid is at rest or in motion. That is the definition of fluid mechanics, students. Now, fluid mechanics categorize into parts, students, fluid statics and fluid dynamics. So, what is fluid statics? Fluid statics, you are doing study of those chapters in which fluid is at rest. That's all, student. Fluid statics. Now, you can say under fluid static, what is the point which I'll discuss? Under fluid static, student, I'll discuss fluid pressure, next Pascal's law, and third is what? Archimedes principles. So these are the major points which I'll discuss. In fact, I'll discuss more point, but what is a crux which I'll discuss in statics. I hope you got it, student. Just confirm me yes or no. Now, students, have a look. That is, I can say next one, fluid dynamics. So, what is the fluid dynamics, students? Fluid dynamic, student, fluid dynamics is the fluid dynamics is the student study of fluid is in motion, right? So these are the student basic bifurcation of fluid statics and fluid dynamics. Now, students, we are going to study fluid. So first, I'll discuss, students. First, I'll discuss what is the fluid. What is the fluid? You can take snapshot, the student. Now, I'm just turning the page so that I can start next concept. So, students, first I'll discuss over here definition of fluid. Or students, before that, I can say, what is the fluid? Students, you can say fluid. Fluid is what you can say. This is liquid as well as what student gas. Both belongs to fluid only, right? So liquid and gases are known as fluids. What students? You can write liquids and gases are known as fluid, right? Now, students, I'm going to tell you what is the definition of what is the definition of fluid, right, student? Any substance, students, any substance which can flow, any substance, student, which can flow, known as fluid, as simple as. Now, students, fluid flow, these are the definition of fluid only. Fluid flow one one place to another place due to, students, it's a markable and major point, due to pressure, due to pressure difference, right? So students, just keep in mind, fluid flow due to what? Pressure difference. Next, student, it will take, students, fluid doesn't have a shape and size. So students, what you can say, it will take, shape of the container. It will take shape of the container in which it is it is placed. So these students, just keep in your mind point under definition of fluid. Students, you can also see one more point. Fluid flow, students, fluid flow due to its own weight. Fluid flow due to its own weight. So these are the students, keep in your mind. This is the definition of fluids, right? So take snapshot of students. Now I'm going to just turn the page. I'll start next topic, right? Students, I can say there is a point which you can keep in your mind. I'm highlighting this point as a note. What is student? As a note. So what is the point, students? In mechanics, in mechanics, we consider we consider solids, students, solids, liquids, and gases. Solids, liquids, or you can also say solid, fluid, and gases as continuous bodies. What is student? Continuous, continuous bodies. So literally, student, it's a highly important. It's a highly important. Just keep in mind. In the mechanics, I can see solids, fluids, and gases, continuous bodies. Right? So these are the basics point, students. So you can just maybe they can ask as a theory questions. Now, students, in our syllabus, mentioned only ideal fluid. So first, I'll discuss assumption of ideal fluid. Right, students? First, I'll discuss this is assumption of assumption of ideal fluid. Right, student? Okay. So what is the first assumption, students? An ideal fluid is incompressible. What is student? Incompressible and non-viscous in nature. Students, I'm going to explaining you what is the meaning of incompressible and non-viscous. So I'll explain one by one. Students, first you can take example that is fluid is students incompressible, right? So students, at any pressure, what you can say? Let us suppose you can say this is the body, this is the container, right, student? This is the container. Okay, inside the container there is what? Fluid. If I'm nothing mentioning, so you can take water, right? Students, you can say this is the container. Inside the container there is a water, right? At any pressure, you can apply pressure from everywhere. So what you can say, student, at any pressure there is no change in volume, which is constant. If volume is constant, students, entire the things mass which already kept in the container, which is also constant. So we can conclude over here mass as well as what a student? Mass as well as you can say for this condition density as well as a student, uh, I can say volume, both are constants. So just note, students, what's the point? At any at any pressure, there is, students, no change in volume, which is Student, which is remains constant, and density is also constant. As I said, density is also constant, right, student? Uh, okay, this is student. An ideal fluid is incompressible. So I explained what is the meaning of incompressible. Now, students, I'm going to explain you what is the non-viscous in nature. So, students, you can say next point, fluid is non-viscous in fluid is what? Non-viscous in nature, right? So, students, what is the meaning of this statement? You can understand. Let us suppose, students, you can take some definition and some idea. This is the fluid flow. I considered there are two lines, but it not a lines. Try to take assumption. It's a water, students, layer of fluids. So let us suppose there is a layer of fluids. This is the direction of force in this direction, and this is what, students, direction of force. It's nothing, student. It's not a force at all. So what is this, students? Friction. Student, this is a force basically. So students, what you can say, friction absent, friction absent only for ideal fluid. Yes, student. Because I can say, students, in our syllabus already I said only ideal fluid is mentioned. So student, what you can say, friction we are not considering according to, because we are learning ideal fluid. Otherwise, you can say friction is there among the layer of fluids. Student, I can tell you more example. What is the friction force? Students, this thing you can treat as like a current is flowing in a conducting wire. So, there is one parameter is there. That is what we are calling resistance, right? So same thing you can say viscous force. There is what non-viscous force. We'll discuss this force. Not here. I can see once I'll start fluid dynamics. For that condition, I'll discuss what is the viscous force, right? So students, fluid is a non-viscous in nature, what implies there is no friction between layer of fluids. Students, again I'm repeating, what is the meaning of fluid is non-viscous in nature. There is no friction between layer of fluids. That's all. Students, now there are four properties of fluids. This is the first one, incompressible. Second is, friends, this is non-viscous. So what is the third one? What is the third one? Friends, the third one is what you can say. You can just make a Roman number A1, 2. This is what? Three students. Fluid has, this is literally very, very important, students. Fluid has irrotational flow. What, student? This is irrotational flow, right? What is the meaning of irrotational flow? Students, you can take example. You can understand. Let us suppose you can say, students, here I'm considering a what? Tube. This is what? Water tube, student. Got it? Okay. Inside the tube, student, there is what you can say water is flowing. Student, what you can say water is flowing, right? Now, students, there is, you can take any plastic ball. Now, students, wall is what? Moving inside. So here, students, what you can say, because this is what we are learning under ideal fluid. So it's a condition for ideal fluid, students. What you can say, there is what? Net, the fluid flow is said to be irrotational. What is, student? The fluid flow is said to be irrotational if there is no net angular momentum at any point. What a student? If there is no net angular momentum at any point. So what you can say, if ball is moving inside the tube, so you need to consider only what? Translatory motion. What student? This is a translatory motion. You don't suppose to take like a rotational motion and all. No, not at all. So what you can take as students? Only student. This is what? Translatory motion. Okay, one more. That is the last one. Property of fluid students. Property of fluid students. Oh, I forgot. You can take a student snapshot. You can take snapshot. Okay. Now, students, I'm going to turn the page so that I can continue next topic or next point. So this is, students, I can say point number 4. So what is point number 4, students? This is, you can say, fluid has streamline flow. What, student? Fluid has what? Streamline flow. In fact, students, I'll discuss types of flow in what? Fluid dynamics. Now you can just keep in your mind, fluid has what? Streamline flow. What is the meaning of streamline flow, students? Again, I'll explain with the help of example. Students, you can take, there is what? Tube. There is tube. This is, you can see for tube outlet point. Student, this is, you can see for tube, it's inlet point. Students, water is, you can say, moving in this tube. Water, students, moving in this tube. Water moving in this tube. So, students, let us suppose I'm considering there is a point. See, this is point A. Students, this point I'm calling point B. So I'm calling students at point A, particular point A, I'm just calling. Student, don't take a wrong perception, which I'm telling you, just that is the fix and that is the true only. Students, you can say this is 10 meter per second. Let us suppose I'm considering over here at point B. This is what the student 20 meter per second. Got it? So what implies point A 10 meter per second? If any fluid particle if any fluid particle cross point A, so what is the speed of that particle? That is at 10 meter per second. I'm not telling students entire tube everywhere particle is moving, fluid is moving 10 meter per second. No, 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 no. What I'm telling students at point A, if any particle is crossing, so this particular point, speed of particle 10 meter per second. That's all. Now, students, at point B, here I'm considering point B that is a 20 meter per second. Same thing applicable. Those particle will touch or cross the point B can acquire 20 meter per second. So what is the meaning of streamline flow? Students, you can just keep in your mind for streamline flow at a any fluid particle which will cross point A. So what is speed of that particle? 10 meter per second. If any fluid particle will cross point B, so what is the speed of particle? 20 meter per second. Streamline flow of a liquid. Streamline, students, I'm just telling you, you can note on the point or I can write. Streamline, student, streamline flow of a liquid. I'm writing here. Normal class, I'm not writing so much, right? Because here I'm live, so I'll write each and everything here only. Streamline flow of a liquid is the flow in which Each element, just understand this one. Try to understand what I'm writing and what I say. Just compare these two students. Each each element, each element of each element of the liquid passing through passing through a point passing through a point travels along the along same path along the same path and students with the same velocity. As I said, students, if any particle will cross point A, will acquire same velocity and same path, same velocity as the the preceding element. What student? As the preceding element, preceding element through that point. Through that point. So these students, I can say point which you can keep in your mind about streamline flow. So which I completed. These are the core point regarding properties of ideal fluid. I hope all of you got this point. Now, students, there is a point types of flow which are discussed in fluid dynamics, not here, because that is a part of fluid dynamics, types of flow like streamline flow, laminar flow, and there are various types of flow which are discussed over there only. Now, students, I'm going to start your core chapters, which I said fluid is divided into parts. That is what, students? I can say this is the point, statics and dynamics. So now, students, which I said, these all points belongs to basics. It's a grooming point for fluids. Now I'm going to start your class for fluid statics. So now, students, you can put the heading. Just write down with me and try to understand the things, students. So now, students, I'm going to start next topic. That is, as I said, fluid statics and dynamics. So this is what, students? Fluid statics. Fluid statics. Already I said, student, what is the fluid statics? We are going to study fluid which is at rest, right? Or students, also you can say, also students you can say in this chapter, in this chapter, we shall study of fluid statics. Fluid statics. Students, what is again? Just you can make another things. Fluid is at rest with respect to container. What is, students? Fluid is at rest with respect to container. That is, you can say another definition of fluidostatics. Right, students? Now, students, I'm going to discuss. There are basic points. So, student, first I'll discuss what is volume. Right. No, students, physics point is a place where you can learn everything from zero to hero. Right. So, what's the volume, students? Space occupied by material is known as volume. Students, again, I'm repeating what is the volume? Space occupied by material in space is known as what? Volume. Students, you can write. What is the unit? Students, majorly we'll discuss in 2 points, SI unit, and next is what you can see CGS unit. Students, for SI unit, you can write meter cube. CGS students, CC, or you can write centimeter cube. Now, students, just move next point. That is, you can say density of a fluid. What, student? I'll discuss all the points. Density of fluid. Okay. So, students, uh, maybe all of you remember here, density of any substance. Student, density of any substance is defined as the mass per unit volume. Students, you can write mathematically, you can write students mathematically, that is density is equals to mass per unit volume. Students, here you need to write what is the SI unit. Students, I hope you remember what is the SI unit of mass, that is kilogram, SI unit of volume, that is meter cube. So you can write SI unit of density. This is what, students? Kilogram per meter cube. Right. Students, here one more point which you can keep in your mind. That is what, student? Density, students, density and volume both are both are belongs to student scalar quantity. So student, take a snapshot, right? Now students, I'll discuss next point. Is there any doubt? You can ask me, right? If you are facing any problem in comment box, I'll back to you now only because this is a live session. Now students, next point I'll discuss. This is relative density. Students, somewhere, some book used to call relative density, or another one also you can say specific gravity. So students, both are synonyms. So you can keep in your mind both of the things. Either you can say relative density, or you can say, student, that is a specific gravity. So student, what is the formula of, you can say, specific gravity? This is density of material or substance, density of substance upon a student, density of water at 4 degrees Celsius. You can ask, sir, why you wrote 4 degrees Celsius? Students, we'll discuss this point. I'll discuss this point in thermal properties of matter, right? This is basically known as what? Anomalous behavior of water. So I'll discuss this one later, right? Just leave it. So now, friends, both are density. So what you can write? SI unit. It's a ratio, students. You can say there is no unit. as well as no student. This is dimension. So these are the points. Students, you can keep in your mind. Relative density, it's a ratio, so there is no unit, there is no dimensions. Now, students, have a look of very basic point. Very few easy questions. Find find relative density, students. Find relative density, or you can say specific gravity. Relative density, students, specific gravity of Mercury, of student. This is what Mercury, right? So there is mentioned density of Mercury, that is 13.6 kilogram per meter cube, right, students? So now have a look of the solution part. No, the caser always solve any question in step. Step one, students. First, I'll write given data. So density of mercury, that is 13.6 kilogram per meter cube. Step two, students. I'll use this formula, that is relative density, density of Hg upon density of water student, right? So relative density we wish to find. So what is the density of Hg? This is 13.6 kilogram per meter cube. Now, students, this is what density of water. Maybe you remember, otherwise I'm writing 1000 kilogram per meter cube. So now, students, you can say cancel. Just divide, students. What you can see, more 13600. This is answer of the student for these questions. So literally, it's very easy. But you can't imagine, you can't give up, you can't ignore of any basic topic. You have to remember, and you have to just keep in your mind each and every concept of physics. Is there any doubt? You can ask to Hikisha at physics point. Now, student, have a look at next question, or I can say next concept question. It's very easy. Now, students, basically, I have to discuss there is a density of nature. Students, this concept, students, I can say density of mixture concept. Okay, student, they asked thoroughly this concept in J 2016. Thoroughly formula only, right? So, student, there are two categories, there are two cases for density of mixture, right? Students, this is case one. This is case one, students. Suppose, students, suppose two liquids of densities rho 1 and rho 2 having having masses m1 and m2 are mixed mixed together. So we have to find the students, find density of mixture. That's all. So it's a questions come, you can say it's a case students. So you can take solution of the questions. So we have to write formula. Density mixture is what, student? This is mass total upon beta g, what you can say. This is density is what? Mass by volume. So you can write over here volume total. So density mixture students mass is what? M. There are two liquids M1. Okay. What is student? They asked the density mixture na? So M1 plus beta G M2. Here is what you can say V1 plus students. This is V2. Now students here I'm going to use the formula of this is rho 1 is equals to M1 by V1 so that I can write V1 is equals to M1 by rho 1. Similarly, students, you can write V2 is equals to M2 upon rho 2. Students, I'll use this result over here only to get answer of this question density of mixture. This is M1 plus M2 students. V1 is what? M1 upon rho 1 plus student M2 upon rho 2. Now just take LCM students. Density mixture. Density mixture student. Just take LCM. So this entire these two things goes in numerator. You can say rho 1, rho 2 student, M1 plus M2. Just take LCM. So this will go this side, this will go this side. Friends, you can write M1 rho 2 plus M2 rho 1. So now students, you can see this is density of mixture. Students, this is the formula which you can keep in your mind now onwards. If there are two liquids in questions mentioned in form of density like rho 1, rho 2, M1, M2. So you will get density mixture formula. But student know what asked by JE. They ask there is, I can say, some simplification of this formula. So what student, if there is simplification, if you can say M1 is equals to M2 is equals to M, then find a student density mixture. So beta Z density mixture, what you can say already we found. Na? We can use student this result as usual. So this is M1 plus M2 rho 1 rho 2 upon beta Z M1 rho 2 plus M2 rho 1. Just now, na beta. Student, just now, na we finished. I derived this result. So now, students, here you can feed M1 is equal to M2. So you can write student density mixture twice rho 1, rho 2. These two are remain same students. You can take M1, M2 common. This is M plus M2M, MM, happy birthday. So you can write this is rho 2 plus rho 1. Students, J asked 2016. I'm not pretty sure, but they asked already this question in 2016. Either JE or NEET. I'm not pretty confident, but I'm pretty sure they asked this question. So just keep in your mind, if there are two liquids, masses remain same. So what's the density of mixture? Twice rho 1, rho 2 upon what students? Rho 1 plus rho 2. Now students, there is one more case. That is, you can say case 2. That is case 2 beta C. If if two liquids, if two liquids of densities rho 1 and rho 2 having volume having volumes V1 and students V2, then the density of the mixture is density of the mixture is, right? So same students, same question which we derived previously, we have to apply same thing. Students, you can say again for solution, this is we wish to find density of mixture. So again, you can write same formula, mass total upon a student. This is volume total. So you can say for density mixture, mass total is what? M1 plus M2. And this is what, students? You can say V1 plus V2. Here, students, again, you can apply same thing. Here, beta, you can use rho 1, V1 is equals to M1. Students, I'm not calculating again. Na? This is same formula. I can apply density is equals to mass by volume. Students, you can say rho 2, V2 is equals to M2, right? So, students, I'll feed this value rho 1, M1, M2 from here only. So, you can write, student, density mixture, beta. M1 is what you can say rho 1, V1 plus rho 2, V2 upon beta g, V1 plus V2. So this is formula, students, which you can keep in mind. Density mixture in terms of volume, right? Now, students, there is this further simplification. There is further simplification. Students, if V1 is equals to V2, then density mixture V1 is equals to V2 is equals to V. Then, students, we have to find density mixture. So already we derived density mixture is what, students? This is rho 1 V1 plus rho 2 V2 upon beta g, what you can say? This is V1 plus V2. What's in the questions? V1 is equals to V2, my dear, is equals to V only. So here you can write a student. This is rho 1 plus rho 2. You can take V common from here. This is 2V. Cancel, students. So rho mixture formula rho 1 plus rho 2 upon 2. So these are the students I can say which I taught about today classes. Right. Take snapshot. Any doubt further, you can just watch anytime this live session. So this is all about student for today class. I'll same time tomorrow I'll be live 7 o'clock. Thank you everyone to be a part of today live session. Now I'm going to just terminate this live session. All the best everyone.